All right, here on page 16, we're taking a look at this here. Now, this is not the new operations that we're going to do. In fact, we're not really going to do a lot of this, especially since we did some of the rationals first. But I did want to show you this here to kind of highlight on page 16 that there's a couple different ways that we could see this. Right here, when we see a plus sign, it really could be rewritten this way. So this right here means that you could add both of the functions, subtract both of them, multiply, and then the last basic operation that we have is division. We've talked about each of those. Now, with rationals, we had to get common denominators, but in just straight adding, and again, this is not going to be something that's on any learning check, this first page right here. You have the two functions with a plus sign between it. Wouldn't this right here be the answer if I combine like terms? Right? I have a 4x and an x. I don't see any like terms with the square root, and no like terms with the 7. Remember what like terms really indicate. Like terms say that they have the same exponent. So recall that the 4x and the x have a x to the first power. But Elizabeth, remind us please, what is the exponent for the square root? Not 2. If I had a square root of x, what would that fractional exponent be? One half, right? Here's the 2. Oops. And here is the 1, right? This is something, that's 7b, that's going to be on the next learning check, right? Just converting back and forth with that idea. But because this is really just a 1/2, again, you don't have to write it, isn't it clear that none of them have the same exponent as a 1/2, right? Like terms-wise. So we could think about these radicals as exponents right now. With the subtraction, it's the same idea. Please be mindful, students, that when you see a subtraction, we've done this on rationals, that you must account for the negative sign with that. So remember, the whole thing is getting subtracted. So instead of it having 5x, Jacob, how many x's would it be? 3x, right? Combining like terms, but now there's a minus sign with it. Luke, instead of it being the positive square root of x, now it's, in my final answer at least,
negative.
There's a negative sign in front of the square root of x, right? So it's got to be minus square root of x. And I guess in this case, the 7 doesn't change just because it comes before. But you could see a scenario where it would. Would I have the same answer if I did the problem this way? Gia? We know adding order doesn't matter, correct? But what about when I subtract? Would order matter when I subtract? Is 3 minus 5 the same as 5 minus 3? So to answer what you said originally, I know I kind of talked over your answer. Excuse me. But yes, order matters when I divide, when I subtract, and so I might get something a little bit different, right? So just be mindful of that. Coming up here. The next thing that you could have talked about was multiplication and division, right? When you multiply f of x times g of x. If I'm just combining like terms, this idea right here is just distributing, right? If I have an x squared minus 9 and an x plus 3, I'm really just using distribution to come up with that final answer, right? Maybe you have a more complicated term, right? Maybe one of them right here has 3 terms. It's just more involved distribution, but that's the idea behind that. And division. If I see f of x on top over g of x, looking at the way that this is written here, x squared minus 9 and x plus 3. Elizabeth, can I just start crossing those off top and bottom, or do I have to do something else first? I can't subtract the exponents. I could if it was written like this, x squared over x, when it was just singular, but Hayden? Okay, I like what you're going at. Maybe not the exact word I'm looking for, but factoring is what I'm asking for. Students, remember, on 7a, you must factor to reduce fractions. Okay? And the same thing happens here. Or excuse me, that was 5a. X minus 3, x plus 3. Julia, do I see anything that's exactly the same on top and bottom of the fraction? X plus 3's, right? So therefore, x minus 3 is my final answer. Nate, similar question to what I asked Gia earlier. Multiplication order doesn't matter, right? Would I have a different answer if I put g of x on top instead of f of x here? Does order matter when I divide? It does, right? 7 divided by 4 is not the same thing as 4 divided by 7. So if I had it that way, it would basically just be the reciprocal, which makes sense because that is the reciprocal right there as well. So again, not seeing any of these here, but I guess maybe a little bit out of habit. I'm so used to using these things to introduce what we're going to talk about next that I wanted to kind of go through some of this idea. As always, remember the video will be posted there on Canvas, so feel free to use this if it's going too fast or things are not kind of clicking the first time. This new operation that I want to talk about is called composition. So on a composition function right here, I have two functions just like normal, right? Just like I had from earlier. When I have those two functions, I'm trying to basically plug a number in and I'm going to get an answer. And then its answer, so plug a number in, I get an answer. Its answer is the new number I'm going to plug in possibly to a different function. Okay? So let me give you some of the forms that we use for this. Like earlier, we saw two different ways. Oopsie. Yeah, there we go. We saw two different ways to write even an addition function. There is two different ways to write a composition as well. One of the ways to write it is just like this. And the way that this is read right here is it says it's g of f of x, right? So I'm going to have a number in that x spot, and basically I'm just going to be plugging it into different functions. Okay? It's almost like it's a function inside of itself. Another way that you could see it is using this notation right here. It kind of looks like a O or a circle, not a dot, but a circle. But again, this is the same right here as g of f of x. So we could see that either way. Now, for our class, we will always have a number here plugged in. There is one question on a homework assignment that has x there. We can talk about what that looks like. But if you can master this skill with the numbers, that's really what I'm looking for. Okay? Maybe on a future learning check, we might see like extra credit problem that has like just the x's in there. But really what I'm looking for is for you to master with this number. Now, here's how I'm going to do this. When I look at this problem, I have two functions, and I have to decide which one to plug the number in first. And here's how I decide that. I look at the problem, and I'm basically going to work backwards through what I see. What I mean by that is this. See how on this first one the G is closer to the 4? That means I'm going to plug the 4 into the G function, and I'm going to get an answer right there. Okay? So I'm going to kind of work backwards through that. Seth, if I plug a 4 into the G function, what answer do I get? 16, right? Its answer is 16. Perfect. Now, what I'm going to do here is I'm going to take that answer and plug it into the next function that's there. Tyler, if I plug a 16 into the f function, what's my final answer? 11. 11 is my final answer. That is what we use with the composition function here. Let's keep going. Take a look at this one. I have a -1 first. Ethan, do I put -1 into the f or the g function first? I have to put it in the f, right? Working backwards through that. When I plug -1 into an f function, I get an answer. Jack, what answer did you come up with when plugging -1 in? -6. Now I have a place to put -6. Noah, what's my final answer when plugging -6 into the g function? 36. And there it is, right there, right? So pretty straightforward. It's not, well, math teacher, it's not hard. Sorry, I'm not saying it's not hard as a math teacher. But it could be a little bit confusing, and just kind of like the notation is a lot different for what we're seeing. Try this one right here. Try that one right there. But whenever you're ready, what is the answer for g of f of 0? She got 25, so we can plug a 0 in. We plug it into the f function first. That's -5. And then plugging -5 into the g, and we get a positive 25. Perfect. Right? Seems pretty straightforward. Couple things I want to note here. Looking at this notation is different. Not in the way that you do the problem, but just in the way of actually working it out. Okay? Let's actually go down here to these two, the ones that have the numbers. We'll come back to this here in a second, but let's skip down here to the middle boxes. And the same order still applies. Jacob, what I mean by that is, if I have a -3, should I plug it into the f or the g function first? The f, right? Because we're going to be working backwards through that. We have the same two functions right here. Jacob, your final answer if you plug -3 in? Okay, let's just check it out. I plug a -3 in, I get -8, but what's my final answer? 64, right? We could do it like this. Do you think order matters if we switch the letters around? Right? Would order matter? Caden, what do you get as a final answer here for f of g of -3, the one that we haven't accomplished? It is not the opposite. We need to do the math to make sure. So do we put -3 into the f or the g first? And its answer is 9. And then 9 minus 5 is 4. Sorry, did you say that earlier? Did you say? Okay. So there it is, right? There's not necessarily a relationship right here that that you have to find. I mean, there will be, but we just haven't got there yet. So right now we're just looking at this. Now, what I was saying here is there isn't going to be something that I'm really focused on having that here. But if we have just the x right here, g of f of x, what I could do is if I do have an x, I know it kind of seems maybe counterintuitive to what we have been doing, I can write the g function down with everything there. See how I basically have written the g function down? I know I didn't write the x, but I wrote something squared. And then what I'm going to do here is I'm going to plug the f function into that as the final answer right there. Now we could simplify that maybe, but this is how you do the, in this case, g of f with respect to x right there. And think about that. That's what we did for this. If I put a -3 in, I get a -8 inside the parentheses. -8 squared is positive 64. We could switch the order. It looks like I have to plug g into f here. So again, it might seem a little bit backwards to how we were just doing it. But if I write the f function down, and then I plug the g function inside of its x right there. Let's see what if Caden's answer matches. If I put a -3 in here, don't I get a positive 9 minus 5, which is 4? Right? So that just is another way to take a look at that. This is obviously helpful. Now I can do it for any number, right? Instead of just the one that we've had. Could you, actually before I ask this question here, let's make sure of one thing. Yeah. All right, flipping it over here onto the next page. Again, we did not talk about a lot of these in depth here, the top 6. There's only one of them that we did talk about in depth. Which one is that? Is that 1, 2, 3, 4, 5, or 6? Which one did we talk about? Which one's the focus on what we're doing here? Are we focused on dots, circles, minus signs, like 2 or 5, plus sign, or a minus sign like number 6? Isn't this one right here the only one that was the composition? Because that was the circle. So just keep that in mind, right? We could work it out. We could say, hey, I'm going to write the f function down first, and then plug in the g function inside of that. Again, that's not something that we're going to be focused on a lot moving forward here. All right, I know it says a challenge, but I think this is necessary for us to do. And these are things that you could see pretty regularly here. Again, really just focused on the composition functions, so 3 through 6 right here. And we're going to use these graphs. We're going to do it the same way. We have an f of x function on the left and a g of x function on the right. Where do I put the 4 in first, Steph? Do I put it on the one on the left or the one on the right? You're right. The one on the right is correct. Right? If I put a 4 into this function, watch what happens. All I'm doing is just finding points. Isn't the point 4, 5 right there? Right? The x is 4, and my answer is 5. Well, now I need to put a number into f. Jack, what number am I putting into f here? For number 3? Or letter C, excuse me. I'm putting a 5 in, right? So now I'm going to take its answer and put it into the f function. So I need to find when 5 is x, what is my y value? And my answer is just 1. So we're interpreting those graphs to kind of manipulate it to what it is. I don't care what the equation is, right? That's not what we're focused on. We're trying to switch back and forth with the x and y's here. Okay? This idea is going to be very important getting to our next topic. This one right here, letter D. We have an x value. Gia, am I putting it in the graph on the left first or the one on the right?
Left.
lefties. If I have x is 4, students, what's my answer? 4 comma 0, right? So I used 4 and I have an answer of 0. Well, that means 0 is now an x on the next graph. 0 comma what on the right? Isn't it 0 comma 2 right here? The next problem is something that I was checking on when I was trying to flip the page and asking him to hold on for a second. Can I have 2 of the same function letters right in a row? I can, right? It's basically, instead of taking a number and putting it into one and then a different one, I'm taking that number, plugging it into a function, and then its answer back into the same function, right? So let's start it out like we normally would. If I put a 0 into the g function, we know that's the graph here on the right. 0 comma 2, right? 0 comma 2. Now I plug a 2 in to that function. If I have a 2 in, 2 comma 0, right? That is just a coincidence here that my answer was where I started. Okay? Just a coincidence, right? I put the 0 in, I got a 2. If the graph was like this, and it even was, somewhere where it was like more of a linear function, it would have been 2 comma 3.5, right? So it just is based on the graph that looked that way. F is another problem that you might see. It's like a challenge problem. Not only do I have to find an answer and plug it into G, but don't I have to take that answer and plug it into F? So it's just adding one more layer to that with a composition. So 7D is composition. See if you can try letter F. See how far you get. Could you just get the first one? Great. That's a great start. Could you get the second one? Perfect. That's exactly where you need to be. But can you go a little bit further and see what your final answer is? Julia, what did you come up with for this first answer, plugging 2 into F? Well, 2 is the x value, right? So 2 comma what is on the graph? 2 comma 5, right? So now I have 5 as my first answer right there. Now where do I put the 5 at? Julia, do I put it back into that same graph, or do I look at the other side now? Because it says G, correct? So now I need to find 5 and look at where that is. Naomi, 5 comma what on the G graph? 5 comma 1. There it is, 5 comma 1. And now the very last thing is putting 1 back into the F. So I'm going back to the F function and looking at x equals 1. Even know what's the last thing? 1 comma 3 right there on that last idea.